All right, so question eight's we have talking about a function that gives a bungee jumper's height as a function of the time since they jumped. Rather than having a graph or an algebraic definition, we have a table with some values of their height in half-second intervals. So first thing we're asked to do is to estimate these three values: h prime of 4.5, h prime of 5, and h prime of 5.5. So there are lots of ways you could get these estimates. They're not really specifying how. I am going to use that idea of a central difference. So if I want to estimate the h prime of 4.5, I am going to do that by looking at what's going on a half second after 4.5 and a half second before. So h prime of 4.5 equals, or I'll say approximately equals. This is going to, all we can do right now is estimate based on what we have. H of 5 minus h of 4 over 5 minus 4. So what is h of 5? 69.8. What is h of 4? That is 55.5. Denominator is 1, conveniently enough. So what do we get? We get 14.3. 14.3, and we should give units here. What are good units to use? Well, we have h prime of t. So what is h measured in? H is a height, and it's measured in feet. And what is t measured in? T is time, and that is measured in seconds. So our estimate for this first rate is 14.3 feet per second. And let's do a similar calculation with h prime of 5. So again, I wanted the half second before. So h of 5.5 minus h of 4.5 over 1 second again. What is h of 5.5? That is 81.6 minus what is h of 4.5? 60.4. So what do we have? 21.2 feet per second. And finally, for h prime of 5.5, we'll take h of 6 minus h of 5 all over 1 second. H of 6 is 93.7. H of 5 is 69.8 over 1. So 93.7 minus 69.8. I believe that's 23.9 feet per second. So we have three different rates. They are all positive. So what does that mean, first of all? Kind of implied by the question. It said, at which of these times is the bungee jumper rising most rapidly? The fact that these are all positive means that at each one of these timestamps, the bungee jumper is rising, because all of these derivatives, all these instantaneous rates of change are positive. The height is increasing as time increases. So for which one is the bungee jumper rising most rapidly? Well, that's going to be the one that's the greatest. So that would be at 5.5 seconds, because that is the greatest value of h prime that we've found so far. All right, part B, use your given data and work in A to estimate h prime of 5, or sorry, not h prime, but h double prime of 5. So we want h double prime of 5. What is h double prime in general? And this is not only true for this function, but true of any function. What does the second derivative tell you about anything? Well, one of the things it tells you is it tells you the instantaneous rate of change of the first derivative. So I can use a central difference again to look at this. Again, like kind of structurally the same way as what I did part A. Let's look a half second above the time we are interested in, and a half second below, and divide that by the change in time. So let's remind ourselves, what is h prime of 5.5? That is 23.9. And what is h prime of 4.5? That is 14.3. All over 1 second. So that comes out to be Looks like 9.6. 9.6 watts. What are the units here? So in the past example, we were looking, or the past part of the problem, it was feet per second, but now let's look at what these units are again. H prime is going to be measured in feet per second, and the time is still measured in seconds. So we can say this is 9.6 feet per second squared. Right, moving on to part C. What physical property of the bungee jumper does the value of h double prime measure? So we asked what its units are. So the units are feet per second squared. But what does it actually measure? Like, what is a physical property? So let's start from beginning here. We are first given a function that talks about a jumper's height or a jumper's position, vertical position, which co-varies with time. So what does the first derivative tell you? Well, the first derivative tells you a rate of change of height with respect to time. What do we call a rate of change of some kind of position with respect to time? Well, that is going to be a velocity. In this case, this specific case, a vertical velocity. How rapidly are you moving upward or downward? If I go one level beyond that, what is the rate of change of velocity with respect to time? That gives you the acceleration of the bungee jumper with respect to time. So as time goes on, how is his velocity changing? And finally, part D, based on the data, on what approximate time intervals is the function concave down? So let's start with that question first. First of all, what does it mean in general about any function to be concave down? So concavity, either downward or upward, that is something that's answered by the second derivative of the function. So we want to know where h double prime of t is going to be concave down. So what about the second derivative indicates whether you're concave down? That comes from where the second derivative is negative. So we don't have values for h double prime, so we can't answer that in the most direct way we'd like to. So h double prime of t is negative. What does that mean about h prime, the first derivative, so the velocity? Well, if the derivative of a function is negative, that means the function that derivative came from is doing what? Well, it's decreasing. Okay, so we're kind of working backwards here. We began with the second derivative of a function. We began with the function h, and we're trying to either, whichever way you want to look at it, work downward towards the second derivative, or start with the second derivative and figure out what that means about the function h. So what does it mean if h prime of t is decreasing? Well, I think that means either one of two things. So let's try to relate this. Let's try to envision what's going on with this bungee jumper. So we know that the velocity of this bungee jumper is decreasing. So I think that can present itself in one of two ways. Let's first consider the bungee jumper going upward. If he's going upward and his velocity is decreasing, I think that means he's slowing down. So that's one thing we'll look at here. Upward, but slowing down. What if instead the bungee jumper is going downward? Let's spell downward correctly first. D-O-W-N-W-A-R-D. If he's going downward and his velocity is decreasing, what does that mean? It should mean that he's speeding up. So he's going downward faster. So downward, speeding up. So let's look for, and let's just do like a quick, we're not going to do any, just for the purposes of this question, I'm not going to go through and calculate all of these subintervals, but let's see if we can kind of get a sense of where this is happening. So let's look from 0 to 0.5. height goes from 200 to 184.2, going downward. Now let's look for if he's speeding up. So what's the difference between 200 and 184.2? That's a decrease of 15.8. What about the next piece here? That looks like that's going to be a decrease of, we'll stop trying to do everything in our head and actually just use calculator if we have. 184.2 minus 159.9, that is 24.3. So is he speeding up? It looks like it. Your velocity was negative and is getting more negative. So I think in this interval right here, between 0 and 1 second, I believe we are concave down. So again, this is something you can use to kind of check a lot of these intervals. Let's just go through one more to kind of spot check. Let's look at what's happening around 8 seconds. All right, so what's happening from 7.5 to 8.0 seconds? Looks like my height increased by 1.7 feet. What about the next second? Looks like my height actually decreased, so negative 1.2. So it looks like the bungee jumper was going upward, and at some point in this interval, reached a peak and started going down. So would you agree that if that is the behavior here, the velocity is decreasing? Hopefully you are convinced that it is. So this is another interval where we have concave down. So I just wanted to show you a couple of intervals where that was the case. But if you want to kind of practice for yourself, I encourage you to try some more of these intervals and see what you come up with.